Hi everybody. In this video, we're going to learn how to make this equation of a line simulator in p5.js. So when I move the dots around on this coordinate plane, it will give me the position of the mouse, the position of the 2 points, and the slope and the y-intercept, and put that in the equation of a line as y equals mx plus b. What are we going to have to do to create this project? First, we're going to have to create a coordinate system in the p5 canvas. Then we're going to create and draw 2 points using a constructor. We're going to check if the mouse is on it and the mouse button is pressed so we can drag and drop these points. We're going to have to draw a line between these 2 points and then calculate the slope, y-intercept, and equation of the line and update all this information on the heads-up display. Let's look at creating the coordinate plane on the P5 canvas first. First thing we're going to have to think about is how we can make the P5 canvas look like the coordinate plane because they use different systems. In the P5 canvas, the origin is at the top left-hand corner of the screen. That's where x is 0 and y is 0. In the coordinate plane, the origin is in the middle of the canvas where x is 0 and y is 0. In the P5 canvas, as you go down, the y value increases. And it's the opposite way in the coordinate plane, where as you go up, the y values increase. So we're going to move the origin or the axes down to the middle of the canvas. And the origin will have an x value of width divided by 2, or the canvas width divided by 2, and the y value of the canvas height divided by 2. And we're going to invert the y values by multiplying them by -1. So instead of going down when y values increase, it will move up on the screen when y values increase. Now let's create our points. So in my P5 web editor, I have a file called points.js. And in my index.html file, I am linking my points.js file to my HTML file using a script tag. So in this points.js file, this is going to be the constructor to make my points. I'm calling it points, and I'm passing in 4 values to make each point: the x position, the y position, the radius, and the color. Each point will be a different color. And I'm just assigning these to these 4 properties of each point. In the sketch.js file, I'm creating an object pt, and that's going to be my array of points. And I'm creating the properties of each point. So ptx will be an array of the x positions, pty will be an array of the y positions, ptr will be the radius, and PTC will be the color array of each point. This will keep track of the color of each point and the text of each point in the heads-up display. And I'm just creating some global variables here, X mouse and Y mouse. That will be the mouse position. P5 keeps track of these using different variables, but you cannot translate them. So I'm going to translate the mouse positions in these variables. M will be the slope of the line, and y-int will be the y-intercept of the line. In the setup function, I'm just creating the canvas. It's going to be 400 pixels wide and high. And I'm creating my 2 points in a for loop. I'm calling my points constructor, and I'm passing in each x position, y position, the 1 radius, and each color each time I call it to create my 2 points. Now we're ready to create the coordinate system and draw everything in there. Inside this draw function, I'm just setting the background color, and I'm calling this axes function, where the x and y axes will be drawn before they're translated. That means I'm drawing them through the middle of the canvas where the origin will be located. So inside the axes function, I'm just setting the line thickness using stroke weight. I'm setting the color of the line, and I'm drawing my y-axis first. It's going to be drawn through the middle of the width of the screen. So up and down from here. So from the top to the bottom. And my x-axis will be drawn from the left-hand side to the right-hand side at the middle of the height, or height divided by 2. Then I'm labeling the axis, so the color will be black, so I'm filling the text with black. And in the text commands, I'm just putting the x at this x and y position, and putting the y at this x and y position. So now my axes are drawn and labeled to where the origin will be translated next. So here I'm translating my mouse position because this translate command does not work on the mouse X and mouse Y variables. The mouse X and mouse Y variables are P5 variables that keep track of the mouse position. So I'm going to translate them in this X mouse and Y mouse variables. So I'm just taking the mouse X position and I'm subtracting the width of the canvas divided by 2. And I'm taking the mouse Y position, and I'm subtracting the height of the canvas divided by 2, and I'm multiplying it by -1 to invert the Y position. Now when I move the mouse up, the Y position increases, and when I move the mouse down, the Y position decreases, just like the coordinate plane. Well, we have one last thing to make our coordinate system. We're going to use the translate command. The translate is going to translate the coordinates of everything we draw after this command. Everything before this command will not be translated by it. So we're going to translate the origin of the canvas to this XY position, the width divided by 2 for the X position and the height divided by 2 for the Y position. Now our origin is at the center of the canvas, and we can draw objects relative to this origin. Now it's time to make our drag and drop points. All I'm doing is checking if the mouse is over one of the points and if the mouse button is pressed. And if it is, I'm making that point position the same as the mouse position. The point position of each point is the center of the point, and the radius of the point is from the point position to the edge of the point. So all I'm checking is if the mouse position on the x-axis is greater than the x point position minus the radius, and is less than the x point position plus the radius. So between the left edge and the right edge. And I'm checking if the mouse position is greater than the y point position minus the radius, so greater than the bottom edge, and less than the y point position plus the radius. So it has to be between the top and bottom edges and the left and right edges. And if it is, and the mouse button is pressed, we can drag this point. And that's what I'm doing here. I'm looping through each point, so both points. I'm checking if it's between the left and right and top and bottom edges, and if the mouse is pressed. Mouse is pressed is a p5 variable. It's a Boolean, which means it's true or false. So if mouse is pressed is true, and the mouse position is over top of the point, we can drag it. Then I'm making the point X position equal to the mouse X position and the point Y position the same as the mouse Y position. Then I'm drawing each point. So I'm setting the color of that point to the color I set in the constructor when making the point, and I'm drawing a circle at that point X position and point Y position and multiplying the point Y position by -1 to make the top of the canvas positive Y. And I'm setting the radius of that circle to the radius of that point that I used in the constructor. And all this is within the for loop. The if statement is just checking if the mouse position is on top, and if it's not, it will still get drawn. And now at the end of my draw function, I'm calling the function calcLine and passing in my points array. And this is going to calculate the slope and the y-intercept. So let's look at this function. So here's my calcLine function. So first I'm calculating the slope and I'm rounding it to 1 decimal place using this round method. So remember, slope is the amount of rise over the amount of run. So I'm taking the difference between the two y values of the point and dividing it by the difference of the two x values of the point. And this 1 at the end means I'm rounding it to 1 decimal place. And here I'm calculating the y-intercept, and I'm rounding it to 1 decimal place using the round method. Y equals mx plus b. I'm subtracting slope times the x value, both sides of the equal sign, and that will isolate the y-intercept on one side of the equal sign, and I can calculate it this way. So I'm just taking the y value of the second point, I'm subtracting it by the slope times the x value of the second point. And then I'm going to draw the line between the 2 points. So stroke weight is the thickness of the line. I'm coloring the line red, and I'm drawing it from the x and y position of the first point. I am multiplying the y value by -1 to inverse the y value so that the top of the canvas is positive y. And I'm taking the x and y value of the second point and multiplying the y value of the second point by -1 to invert the y value. Okay, now I'm updating the information in the HUD function. I'm passing in my X mouse and Y mouse values, as well as my points array, the slope, and the y-intercept. So here's my HUD function, and I'm coloring each text a different color. So the fill will be black for the mouse position, and I'm just putting the mouse X position with its variable here, and the Y position with its variable here at this XY coordinate. And for the blue point 1, I'm putting its X position and its Y position at this XY coordinate. And for point 2, I'm coloring it green, the same color as the point 2 color. And I'm putting its X position, Y position at this XY coordinate. And for the slope and y-intercept and equation of the line, I'm using red text, and I'm putting the slope and the y-intercept at this xy position, and my equation of the line with my slope and y-intercept at this x and y position. And that's all there is to it to making an interactive equation of a line simulator.